Find integration root over cot x plus root over tan x dx. Now first taking root over tan x common, we get integration root over tan x into 1 plus cot x dx. Now putting tan x as t square, we get dx equals to 2t dt divided by 1 plus t to the power 4. Therefore after substitution, I becomes integration t into 1 plus 1 by t square into 2t divided by 1 plus t to the power 4 dt, which is equal to 2 into integration t square plus 1 divided by t to the power 4 plus 1 dt. Now we divide the numerator and denominator by t square and then write the denominator as t minus 1 by t whole square plus 2. After doing this, we put t minus 1 by t as y. Then after substitution, I becomes equal to 2 into integration dy divided by y square plus root 2 whole square, whose value after integration is root 2 into tan inverse y by root 2 plus c. Putting the value of y, we get root 2 into tan inverse t minus 1 by t by root 2 plus c. On further simplification, we get the answer as root 2 into tan inverse tan x minus 1 divided by root over 2 tan x plus c. Let's take an example. Find integration sin 2x into cos 2x dx divided by root over 9 minus cos to the power 4 2x. Now here putting cos square 2x equals to t, and after making the substitutions, we get I equals minus 1 by 4 integration dt divided by root over 9 minus t square. So on integration, we get minus 1 by 4 sin inverse t by 3 plus c. Then putting the value of t, we get the final result as minus 1 by 4 sin inverse 1 by 3 cos square 2x plus c. Evaluate integration minus 1 to 3 by 2 mod of x sin pi x dx. Now here we see x sin pi x is positive in the interval minus 1 to 1 and is negative in the interval 1 to 3 by 2. Therefore, we break the integration in two parts such that we get two integrals, minus 1 to 1 integration x sin pi x dx, and another is 1 to 3 by 2 integration minus x sin pi x dx. Now integrating it and then putting the values and simplifying it further, we get the final result as 3 by pi plus 1 by pi square. Evaluate integration 0 to pi x dx divided by a square cos square x plus b square sin square x. Now by using the property 4, we replace x by pi minus x and then break the integral into two parts. We get pi into integration 0 to pi dx divided by a square cos square x plus b square sin square x minus integration 0 to pi x dx divided by a square cos square x plus b square sin square x. Now you will note that the second term is nothing but I. So taking it to the other side, we get 2i equals pi into integration 0 to pi dx divided by a square cos square x plus b square sin square x. Now we write the integral as pi by 2 into 2 integration 0 to pi by 2 dx divided by a square cos square x plus b square sin square x. Now you will note that we have changed the limit over here from pi to pi by 2. Now further, dividing the numerator and denominator by cos 2x, we get pi into integration 0 to pi by 2 sec square x dx divided by a square plus b square tan square x. Now putting b tan x equals to t, so that b sec 2x dx equals to dt. Now after further substitution, we get I equals to pi by b into integration 0 to infinity dt divided by a square plus t square. After integration and putting the limits, we get the final answer as pi square divided by 2ab.